from today. But I don't actually know. We can take a look at the schedule. Now that it's finally back on live. Videos from Monday are posted now. I did that yesterday. That's us. Exceptions. No. Next class. Did we talk about exceptions in Visual Basic?
Yeah.
Okay. Exceptions are one of those things that you can, I probably mentioned this already, but you can get away without using, but they're so heavily integrated into the language that whenever Java encounters something where it will break, it throws an exception. So it's a good idea to understand what they are, how they work, how to unexceptionify your code, which is usually what I end up doing. But exceptions are, we'll talk about them on Monday. But they are useful, even though I don't particularly like them. All right, so interfaces and abstract classes. I'm actually going to go in the reverse direction, abstract classes and then interfaces. Any questions on section, I don't know what this is, 8.4? Yes, 8.4. Cool. So, I've mentioned a couple times while we were writing classes, normal classes, that something called the public interface of a class. And in Java it gets kind of confusing because the term interface is overloaded. Interface is both a specific construct in Java and a general concept. The idea being just like the interface of anything else you would encounter in the real world. The interface of some big complicated piece of machinery is the control panel. It's basically what something outside the system sees. So when you're using some big, massive piece of machinery, like walk down this hallway, there's tons of examples. I don't know what goes on inside it, but there are panels with buttons and lights and knobs and stuff like that. And knobs and buttons and lights are things I understand. In the context of Java, something outside a class you're writing doesn't really care what's going on inside your class, and most likely wouldn't know how to use it if it could see it. So it interacts with your object through methods. If you have any public instance variables, which, by the way, are bad, it can interact with them. So it's mostly through methods. Accessors, mutators, and other methods that do stuff. And we can talk about that as being the interface of a class. However, interfaces are something in their own right. There is a Java keyword, interface, that you can use to specify, here is a set of interactions that I would use to interact with something that is kind of this type. So there are things like iterable. These are examples in the Java framework. Iterable, which means that this is something that has a bunch of other stuff and I can iterate through it. There's also a very similar one called iterator, which basically says this provides methods that allow me to iterate through something. There's one called comparable. Different people pronounce it different ways. That basically says this class, or this provides methods that allow me to compare this class to other things. And a lot of them are pretty simple, but some of them can get very complicated. And there's actually a distinction. Let me turn off the lights here. In the Java framework, in the documentation, anything that's italicized is an interface. So let's see if the wrapper types are always good. Let's find double. Come on. There are a lot of classes in the Java framework. Getting close. Double. Okay, so double is a class because it's not italics. And here in the documentation, there's a section for implemented interfaces. This means that this class is declared as, there's no better way to describe it in English, implementing these interfaces. In some ways, it's nice when programming languages use English words as you would say them, but in other ways it gets confusing. So, and I can't really put my speaking in monospace type or normal type. It just doesn't work that way. So, basically, this is an is relationship. A double is serializable. I'll explain what that is in a minute. And it is comparable to things of type double. That's what those angle brackets mean. Those are something called generics, which we aren't going to talk about in this class, which the Java framework is now flooded with. So eventually it'll be good to talk about them and understand what they are, but right now we can just ignore them. And basically this means that other parts of the program can say, I want something that is comparable. And we've already talked about inheritance, so we used the animal example and we talked about dogs. No, we talked about badgers. So if I have a method that takes something of type animal, I don't care what actual type of animal it is, so I can pass a badger to that method, and it will work fine because badger is an animal. That's a kind of a, I want to say it's a noun relationship. This is a subtype. Great, another overloaded Java term. A badger is an animal, but they are both things. Whereas this is more an adjective relationship, sometimes an adverb relationship, meaning that I can do certain things to a particular class. So I don't know, are badgers comparable? We didn't implement them as such, but I could write a method that says, I want something that is comparable. And I could use it just like any other type. So method compare comparable t. I don't know. Some identifier. So instead of saying, I want to specifically compare badgers, I want to compare something that is comparable. I don't care what it is, as long as it implements the proper methods in order to be comparable. And the assumption is that if something implements that interface, this is something that's enforced by the compiler, the assumption is that if something implements an interface, it also implements the methods that that interface says, these are the methods that something that implements this interface shall define. And then you can use those methods without knowing anything else about the class. Just by knowing that an object is comparable means that you can compare things to it. Whereas if you asked for, say, an object, you have absolutely no idea what methods it has. So I mentioned I'd say what serializable meant. Serializing is essentially taking a class, which is some arbitrary representation that Java handles, and turning it into something that is a sequence of characters, basically. Can be binary, can be text, but somehow turning it into something that you can save in a file or send across the network. Because classes themselves don't really save to files very well. So that's just we're not going to actually use serializable, but that's something that's there in the Java framework that a lot of these classes implement. And up here, just for completeness, this is the inheritance hierarchy. So double is a number. It extends number. And see that right there. And number implicitly extends object. So at the root of every inheritance hierarchy in the documentation, you'll see object, java.lang.object, and then things inherit from that. So, right, we've talked about what an interface is and what an interface is. We've talked about what an interface is in terms of the English term and how that manifests itself in terms of Java. And in a minute, we'll actually write an interface to create our own interface. And to sort of motivate the need for interfaces even more, it's one thing to create a example on the spot. It's one thing to create a double, an integer, the classes. A class double, a class integer, a class character, a class long, and implement the same methods on all those classes. But because of the way Java handles types, just implementing those classes doesn't mean that we can create one method that can accept variables of all those different types. We can't assume that all of those types have the same methods, because there's no way of saying all of these classes have all the same methods. Interfaces, the actual explicit definition of an interface, provides that. It says everything that implements this interface all implements exactly the same methods. So I can assume that a method that I write for character using all of this subset of methods will also work on double, long, what did I say? Integer, double, long, character. It'll work on all of them. But because of the inheritance hierarchy, I can't specify the type of the parameter as one of those specific types. I have to specify it as the type of the interface. So a method would take it comparable, and then it would work on all the others. So that's not this class. I'm going to open up, that's convenient, the first two, animal and badger, and what was it, animal test or something like that? OOP demo, okay. So, this is all the stuff that we made last time. And something in animal should scream. Oh wait, I haven't talked about abstract classes yet. So I'm going to talk about abstract classes now. One of these things here should scream, what is it doing here? What's its purpose? And that's move. I know I can move, but I don't know how. So we're declaring a method that does absolutely nothing because we don't know how, because we haven't specified what type of animal this is. So it would be really cool if we could say an animal should be able to move, but each individual animal should specify how they're going to move. So animal doesn't have a default way of moving, but every other animal knows how it's supposed to move. A badger is going to crawl, a snake is going to slither, a dog is going to bound, a cat is going to slink, and you can go on and on from there. But to this point, we don't know of any way to do that. We'll change that. There is a keyword called abstract. And this means this class is not providing an implementation for this method. It is up to the responsibility. Wow. it is the responsibility of classes that extend this class to provide an implementation for that method. And actually, the error that Java will give me is probably not the one that I'm going to talk about, but Java will not let me provide a default implementation for this method, because I'm saying this method must be overridden in a child class. However, I am giving it a definition. That doesn't make any sense at all. What it will give me is the error, that's not what I expected at all. Animal is not abstract and does not override abstract method move in animal. Don't worry about that. That doesn't make any sense. What it really means is that if I have a method that is declared as abstract, the class itself must be abstract. The abstract keyword on a class means that you cannot create instances of that class directly. You have to create a subclass, you have to extend that class, and then you can create instances of that class. And it makes sense that if you have a method that is declared abstract, the class must be abstract, because if you can still create instances of a class that has an abstract method, that creates problems, especially if you try to call that method. There's no definition for that method. And I'm actually going to rearrange these keywords. They are valid in both orders, but the convention is that the visibility modifier comes first, and then abstract or final, if either are specified, come next. I talked about final last class, correct? Yes, okay. Then the return type, and then the name of the method. And static, if it's static, goes in there between the visibility modifier and abstract or final. So to have all of them in a string, you'd have something like public static final void main, if you really wanted to. Usually you don't see abstract or final and static together. It gets kind of wonky that way. Though if you have a name constant, then you see static and final together, but that's not a method, that's a variable. So now that I declare the class as abstract and the method as abstract, now it should give me the error that I was saying it would give me. Abstract methods cannot have a body. I can't say this needs to be defined somewhere else and also give it a definition. That just doesn't work. So instead of having a body, this just gets a semicolon. And then I can, that class compiles. So everything with animal is fine now. Now it is complaining that Badger, which extends animal, it inherits from animal, so it automatically has everything that animal provides, is neither abstract nor does it override the method move. So specifying the abstract method move in animal means that everything that subclasses animal must define the move method, or it can be abstract and delegate definition of that method to something further on down the chain. We want to be able to create instances of Badger, which means we have to override the move method. So let's do that. In order to override a method, we use the exact same signature. And you can either, you can make that statement true either by saying that the word abstract is not necessarily part of the signature, or by saying that the exception is when you're overriding abstract methods. Because we don't want this method to be abstract, we don't specify abstract, even though we're overriding an abstract method. So it's just the rest of the signature. So public void move, and
System.out.println, since I am a badger, what did I say? Crawl. And now Badger compiles.
Now, OOP demo does not compile because we're creating an instance of animal, and since animal is now abstract, we can't do that. However, even though we can't create instances of animals, we can create variables of type animal. And a variable of type animal can hold anything that inherits from animal. So it can hold badgers. If we created, what were the other examples? Snakes, cats, dogs, and all of them extended animal, we could save any of those inside animal. That's useful if we just want an animal, we really don't care what type it is. We're just dealing with an animal, and we're not dealing with anything that specifically relates to dogness or catness, but only things that pertain to animalness. So here, since we don't have dogs, cats, or snakes, let's create a new badger. And now that line will compile. So we're creating a new badger and saving it in an animal, because a badger is an animal. Note that if we created methods on badger that were not an animal, for instance, if we were to do something like that's a terrible method name. Is badger return true. Obviously, that's a ridiculous method. But if we created a method in Badger called isBadger, we could not, even though we know from this line we are storing a badger in animal j, we could not say j.isBadger, because the main reason is that the Java compiler is not that smart. It looks at line 11 pretty much in isolation from everything else. Says J is an animal. Animal does not have an isBadger method. I don't know what that is. And I should implement the method properly. So there it says cannot find symbol isBadger on class animal. Question.
This might be a little off. So when you on my laptop, when you created animal, you put an constructor. But if you can't use it, then all you need to do is extend it to add another variable type. You still need a constructor for animal if you do anything like that?
That is an awesome question, and I've never actually thought about that. So basically, the start of that question is, I am creating an abstract class. Since this class is abstract, I cannot make instances of it. Therefore, it does not make sense to have constructors of this class. And before you ask that question, normally I would say yes to that question.
But would you be able to do a new badger?
You can create new badgers because it's not abstract. However, animal is abstract and has constructors, which, even though they are not useful to create new instances of animal, they are useful right here. It is useful for an abstract class to know how to construct itself for the sake of its subclasses. That constructor in animal will never be called directly on an animal to create a new animal. But it is useful to say that things that are animals should know how to do all its animalness stuff. So calling the constructor, the super constructor, from within the badger constructor does work. Did everyone follow his question and the answer? Okay. So,
However, since we know that J is a badger, it's kind of superfluous that we're calling the method is badger.
because it's going to return true. But we could, since we know that J is of type badger, we're creating a new badger and saving it in J. We can actually cast this to a badger. Casting animals just sounds like a recipe for animal cruelty.
And so cast J, which is an animal, to a badger.
And then once Java knows that it's a badger, we can call the badger methods on it. So we can call isBadger, and that will work fine.
So just like we can cast primitive types, we can cast reference types.
So going up the chain, up the inheritance tree, like here, a badger is an animal.
We can store a badger in an animal directly. We don't have to do any casting because a badger already is an animal. However, going down the inheritance tree, we do have to specifically cast to say, Java, I know that this might be dangerous, but I specifically want to do this. If J were not a badger, for instance, if we created a snake class that also implemented extended animal, and we tried to cast J to a badger, you can't cast a snake to a badger because snake does not. Badger does not snake. No. You can't cast a snake to a badger because neither inherits from either. It just doesn't work. So then you would get an invalid cast exception. Your program would blow up and bad things would happen. In fact, let's do something that's totally wrong. Right? There's no way J is going to be a scanner. A lot of times the Java compiler will actually catch that and say, you can't do that. What are you trying to do? Now, if we choose object, both things eventually inherit from object. So this will compile, because scanner and object are part of some inheritance tree. There is some path between them. So it's possible that I originally stored a scanner in object J. We all know that I didn't. So when I run this, bad things will happen. Badger cannot be cast to scanner. Class cast exception. So moral of the story is be careful when you're casting. You can do it. You can change subtypes into supertypes and the supertypes back into the subtypes they originally were. But be very careful about it. Keep in mind that inheritance hierarchy. So let's get rid of that. Let's change this back to an animal. Okay, so that's basically abstract classes. Note on the use of abstract, it does not make sense to make variables abstract. I don't even think you can do it. I don't think Java allows you to do it. Right. So
continuing in that direction, we can make all of the methods in a particular class abstract.
That is useful if we want to say things of this subclass have these methods. I don't know what their implementations are going to be until you subclass this class, but it should have some instance variables, some internal state.
In that case, have I talked about protected yet? Okay. So in that case, it doesn't make sense to have any of those instance variables in the abstract class be private, because then nothing can access them. It makes sense for all of them to be protected so that the subclasses can access them in their implementation of the abstract methods in the parent. But if we don't have any instance variables, if we just have abstract methods, let's do that. Let's get rid of these accessors and mutators. They're just going to be irritating. Actually, trying to figure out how I can verbify animal. I'll call it living. So let's start by doing that. And I'm going to take all of this, all of the doing stuff, not the accessors and mutators, and put it in this living class. And make all of these abstract. You can have a final method inside an abstract class. That does work, as long as you provide a method body for it. That means that the class must be extended, but that method always has that implementation, no matter how many times you subclass it. No. So I ended up, I actually had celebrate birthday being final. So animal could not be, I could not create instances of animal, but I did want to enforce that all animals celebrated their birthdays the same way. So that's why I would do that.
Okay.
So I provide a default implementation. I make it final so that nobody can change it. Correct. Yes. You can't have something be both final and abstract. That is correct. So I'm actually going to copy those implementations back here. So that all animals automatically have the ability to eat. But I'll take out these implementations here so that the definition of something that lives
doesn't necessarily all eat the same way. For instance, plants do not eat the same way as animals. They don't want to eat objects, they want to eat sunlight and sugar.
So all of this is still valid. Well, we can't have a method definition and the abstract keyword. So let's just take that out. And we'll also put that in. I'm just trying to figure out how to maintain functionality while still getting toward a very, very bare abstract class. So this abstract class really doesn't say anything.
It says there are specific methods which
need to exist.
Which really is defining an interface. We're not providing any implementations for anything. We're just saying that in order to be living, it needs to implement these 4 methods.
So we can we'll start with that. And right, speak does not have an implementation in super, so we'll just comment that out. So everything compiles.
But there's no reason for this to be a class, since we're just saying this is the it's a very passive thing. It's something that is living will define these methods, but at the point of declaring living, we don't know how they're going to define those methods.
So we can turn this into, instead of an abstract class, just have an interface.
And basically what that means is we are defining the interface in terms of the English word for some set of classes.
And then these methods, we no longer have to specify abstract because we can't actually specify a method body in an interface. That's not what an interface is. So it's just the actual signatures of the methods. And basically what this is saying is
anything that implements the interface living must define methods with these signatures. These 4 methods with these 4 signatures.
And the syntax for that is slightly different. Instead of extending an interface, we extend another class, but we implement an interface. And the term for that is implements.
And it doesn't have to be a strict inheritance hierarchy like we have here. It doesn't have to be an interface at the top, then an abstract class, then subclasses of that. We can have interfaces over here, abstract classes over here, and then subclasses of these abstract classes implementing interfaces over here. And that's exactly what we saw with double. Double implemented comparable directly,
but it inherited from number. And I think I still have that. Yes. So double implements comparable, does not implement serializable, but the documentation says that it implements serializable, which means that most likely number directly implements serializable. And that is correct. So, in essence, excuse me, double does eventually implement serializable, but that's because its parent class implements serializable. So why is it useful, aside from varying degrees of declaration and definition within abstract classes and interfaces, why is it useful to have both? Why does Java have classes and interfaces? Why isn't everything just a class and some have more definition and some have less? And the answer is something called multiple inheritance. Some languages, C++ is the big one, allows something called multiple inheritance. That means that a class can be a subclass of two other classes, which works most of the time, but gets really confusing when both of those parent classes implement a method with the same signature. You get the question of which implementation am I going to use? I believe C++ solves that problem by just breaking horribly. Java's approach is that breaking horribly is bad. So it goes toward the everything talks to each other through the interface idea. So if we end up with two interfaces that both say you need to declare a method with the same signature, for instance, both two interfaces specify an add method that has a void return type and takes an object. There's no issue there because all an interface is saying, there is a method with this signature. Both interfaces are saying the exact same thing. There's no ambiguity. The class implementing those two interfaces needs to implement one method that has that signature, public void add object O. It will satisfy both interfaces. There will only be one method. There's no confusion whatsoever. So you can only extend one class in Java. However, you can implement multiple interfaces. And let's go back to the documentation. Let's see if I can find something that implements a lot of different things. The names in Java are pretty useful. So let's search for extends writer. Implements appendable, closable, flushable. Notice here it's very, very verbish, or adverbish, I guess. The names of interfaces describe things you can do to a class, because that's exactly what they're specifying, is methods that these classes need to implement, things that can be done to this class. So basically you can look at a writer, whatever a writer is, and say, oh, I can append to it, I can close it, and I can flush it. And I think each of these interfaces only defines a single method. Closable says you have to declare a close method. Flushable says you have to declare a flush method. That's there. And appendable says you have to implement three methods, all called append. So in general, interfaces are very
short.
There is one that is not short. Let's see if I can find it quickly. Map, which
Means that you can take a value of one type and map it to the value of another type. It's sometimes called a dictionary in other languages.
This is an interface that says you must declare a lot of different methods. So implementing those interfaces is not quite so fun, but most of them are pretty straightforward. And you'll notice that one of those that I clicked on was called Abstract Map. There are a lot of instances in the Java framework where there is an interface and there is an abstract class that implements that interface that provides default implementations for all of those methods. And they're named abstract and then the name of the interface. And then there are, I guess the opposite of abstract is concrete. Actual classes that do implement all those methods that you can create instances of. But when you get into interfaces and abstract classes, you can kind of snowball into a whole another level of complexity that is kind of overwhelming. So, questions on abstract classes and interfaces. I probably could have divided this living interface into 3 different interfaces. One, something like vocal, meaning it defines a speech method. It shouldn't be edible, though following the naming convention, that's how it would work. Adding able to the name of the method that it says you must define. Locomotive for move, feedable for eat, something like that. And then animal or something further down the chain could implement those individual interfaces. And here, even though, oh, right, I missed something. So, just like abstract classes, I can't create an instance of them, but I can create variables with that as the type. I can do the same thing with interfaces. So that will work. And as long as I don't call any method that's not specified by that interface, I can do that. If I want to call a method that I know is on the actual type, in this case a badger, but not on the interface, I do the same thing as I did before. So I can still do the badger j dot is badger. That will still work even though the type of the variable j is living. So let's see, to give kind of a more concrete example, let's see how you are supposed to use this in the next homework assignment. that doesn't involve it because that's due 6. That's due in a week from Monday, in 4 days or so, right? 23, yes. So it wouldn't be in that one. Implement a well-known interface in the Java framework. Looks like this one has been done. Ah, yes. Look up the Java documentation for the iterable and iterator interfaces. I mentioned these interfaces at the beginning of class. These are probably the most widely used interfaces, and they are used on things called collections. Basically, it is an official Java term, but it's also an English word describing a set or something like that. A thing that is composed of many other things, which is exactly what we're implementing with Fleet. Fleet eventually will be a thing, a fleet, of many other things. Eventually an array of cars. I don't remember if that's this assignment or the one that's... It's in 6?
6 is array.
6 is arrays. Okay, so you implement a fleet with arrays in programming assignment 6, and then here you take that array and use interfaces with it. In particular, the iterable and iterator interfaces. And this allows us to use this for each syntax. Highlighting doesn't really highlight on this screen. This for each syntax. So we've seen that with arrays. For a specific item in an array, we can also do for a specific item in a collection. So fleet will become a collection, and each item in the fleet is a car. And like I said, both of these methods, both of these interfaces use generics. Don't worry about the generic part right now. All of the documentation says iterator angle bracket E and iterable angle bracket E. In your code, just replace the E with car. For now, replace E with car. And define your iterator method as returning an iterator car. So if we look at the API documentation, if we look at the documentation for iterator, actually, let's start with iterable. Iterable. Implementing this interface allows an object to be the target of the for each statement. Basically allows you to iterate over things. And all it says is that you have to define an iterator method, a method called iterator that doesn't have any modifiers, must return something of type iterator and then whatever t is. In this case, I say that t should be car. So basically, iterator over cars. And in the assignment description, I say that the convention in Java is to simply return this, this keyword. So that method has one line in it, and it is return this semicolon. And in just a minute, I'll actually do an example of all of this iterating stuff. So it returns an iterator. Okay, so what is an iterator? And I'm saying it returns this, which means this particular class, in this case fleet, must also implement the iterator bracket car interface, which specifies that you need to implement 3 methods. Has next, which returns a Boolean. Next, which returns an E, which means it returns a car. And remove, which returns a void, or has a void return type. And the important ones are has next and next. If you don't implement those properly, that for each loop that loops over your fleet will not operate. It won't work. Remove, we're not actually going to use, so you don't have to worry too much about that. I think the implementation for that is actually probably documented as don't implement anything there, just stub it out. Too far. Right. For iterator, we must implement 2 methods. The third is optional. Has next, next, and I don't say anything about remove.
Because it doesn't take any arguments and doesn't have a return value, you can make the implementation of the remove method an empty implementation. Just open curly brace, close curly brace. Doesn't have to do anything. We're not going to use it. If you're actually creating a collection class, you should implement that method, but that's beyond, that's more into data structures. And so let's actually use this. We're going to, I have 7 minutes. I can do it in 7 minutes. I want to create a class called Array Wrapper. No. Integer Array Wrapper. So this will wrap integers. This will be basically like your fleet, minus some functionality, except it will deal with ints instead of cars.
So I'm going to say that it will iterate and be iterable. So implements iterable on integer. I can't use int, the primitive type, because that's a primitive type, not an object. All of these this generic stuff must be objects, so I actually have to use the wrapper class integer. But Java automatically converts between int and integer, so in the actual code I'll be using ints, except where integer is specifically needed. And we will also implement iterator over integers. And if we try to compile this now, it says open curly brace expected. What? Implements. Yes, that would do it. Okay. Implements. There we go. Integer array wrapper is not abstract and does not override abstract method iterator in java.lang.iterable. So let's start there. Let's implement a method called iterator. Public method. We know it must be called iterator. Looking at the documentation, it does not take any arguments and returns something of type iterator and this same type that's specified in the name of the interface that we're implementing. So iterator over integer. And that's exactly why we implement iterator on integer so that these types match up. Our implementation for this method is very simple. This will be the iterator for itself. And we should also have a pointer. I'm going to call it a pointer. It's just an int that represents the index to the current. Technically, it's the next element in the array, but the one that's currently being dealt with. So it should start off at 0, and in my iterator, and this is specified in the program description for programming assignment 7, it says this method should reset the value of the current pointer. So current equals 0. So now it complains that it can't find the symbol iterator. That's because iterator is not in java.lang, it is in java.util. So we have to import it, just like we have to import scanner. And now it should start complaining that I don't know why it starts complaining with the method remove, but it starts complaining that I'm missing methods that are specified by this interface. So we'll start with remove since that's what it's complaining about first. We can look at the documentation and see that it needs to be a void method, and I said that our implementation should be empty. Does not implement next. Now's a good time for us to start putting together the data that will actually be returned by this this integer array wrapper. Actually, let's do something clever. Before we implement anything having to do with the underlying data storage, which in this case will be an array of integers, we'll implement that next method. But so since this is an iterator over integers, it must return an integer. Next. And I'm simply going to return current. So the first time it's called, it will be 0, and then in theory, the way that this pointer will work, the first time it's called, it will return 0, the next time it will return 1, and so on and so forth. So we'll try to compile it. And now it says no method has next. So let's implement that. Public Boolean as next. So return current less than 10. So as long as current is less than 10, it will continue to return true. I'm actually going to increment current there so that the first time next gets called, it will increment current to 1, return that. The next time increment current to 2, return that. And if you look closely, you can see that these are basically the parts of a loop. Basically the parts of a for loop. And I'll actually use those as the parts of a for loop before I use the for each syntax to demonstrate how these methods are actually used. We have, in a for loop, we have the initialization, the test, and then the approach. The initialization here is the iterator method. Getting an iterator, resetting the pointer back to the beginning. The test is whether or not there is a next thing, the hasNext method. And then the approach is actually get that next thing. So I'll just use OOP demo. Haha, it does work. That was Command / on my machine, so it's probably Control / on your machines. Very convenient. So let's create an integer array wrapper. W equals new integer array wrapper. So there's our initialization step. We're getting the iterator. Our test is if iter has a next, and then our approach is, let's say, yes, this is valid. It's kind of a lot in one statement, but
It's a valid expression. So we'll get the next one. That will get returned, and we're immediately printing it out.
so if we run this, cannot find symbol. Yes, that's right. Because we need to import iterator. When you actually use the for each syntax, you do not need to import iterator because you never directly use iterator. And it prints out the numbers 1 through 10.
Any questions on that?
So now let's use the for each syntax. Here we can actually just use int, because
The primitive type int and the object type integer are pretty much interchangeable. The only difference is that when you need to specify an object in a particular place, you need to use integer.
so everything in the implementation of the iterator uses integer. If I tried using the primitive type int, it would complain. So here I'm just going to integer array wrapper. System.out.println. Both of these 4 lines and these 2 lines do exactly the same thing.
They will get compiled into exactly the same Java bytecode.
And we'll show that they run exactly the same way. They do exactly the same thing. Questions so far? I'm running a little bit over time, but We'll be done in just a couple minutes. That's cool, except integer array wrapper is not doing anything real spectacular. We're just iterating over the same numbers over and over again. It's always going to print out 1 through 10. So let's create an instance variable called data. We won't give it a value. We'll specify a constructor to force there to be no noargs constructor and only be a constructor that takes an int array. Integer array wrapper. Okay, public integer array wrapper. Int. We'll call that in. And all the constructor will do is set data to in. Obviously, this step, how your array of cars actually gets created inside Fleet, is different. Will be different. You're not just going to pass in an array of cars. You actually have, I think, an add method. So now we want to use these, use this array inside the iterator methods. This doesn't have to change because it doesn't actually use the array. Current just gets set to the first index of the array. HasNext should somehow check if there are more elements in the array. So this should be return current is less than the length of the array. And this, instead of, it should still increment current to point to the next element. However, it should return data current. Slight problem with this. The first time that next gets called, current is 0. It will get incremented, and then it will return the item at index 1 in data, which is not the first element we want to return. So we actually need to do these things in opposite order. It would be really nice if we could say return data current and then do the incrementing. Java doesn't work like that, so we actually have to say integer temp equals data current. So that gets the thing we're going to return. Then we do the incrementing, and then we can return temp. And all of that did compile. What it's complaining about now is that there's no constructor to integer array wrapper that doesn't take any arguments. So let's put an array there. Let's say 5, 4, 3, 2, 1. That's an array literal. That's an array of 5 elements. Their numbers are 5, 4, 3, 2, 1. Compile that, and fine. Int temp equals I think they fixed that in Java 7, so it doesn't work on my machine, but it would work on yours. And now, if we run this program, it prints out 5, 4, 3, 2, 1. And The iterating stuff in this class is very, very, very similar to what you will have to write for programming assignment 7. The differences being mainly that every instance of integer should be replaced by char. And some of the instances of int, like on line 5, int brackets data, that needs to be an array of chars, which you'll deal with some other way, not through the constructor. This was just for demonstration here. But iterators are very, very powerful, very nice when you have them, and not as nice when you don't have them. Pretty quick to implement, especially on a, this is really a data structure, as simple as an array. So, questions on that? Cool. So, we'll take a break. When we come back, you can work on programming assignments, ask me questions about them. I can also pick out a couple programming projects now that we're done with the chapter to give you some more practice with the whole inheritance thing with abstract classes and interfaces. Cool.